Okay, so if one of you could just confirm you can see it saying integration by parts, that would be great. Thanks.
I can confirm that that is what it is saying.
I can't see it at the moment.
Thank you. So
I can't actually see it at the moment.
You can't see it?
No, I've just got your logo. The logo.
All right.
Okay, there we go.
You got it. Yeah. Okay. Right. So we carry on wading our way through this huge chapter. Yeah. Okay. Thanks, Tom. You used the mic now. Thank you. So yeah. So we've got integration by parts, which is the bit we'll look at today. Then there's going to be integrating when you do some partial fractions first, just to simplify things. So that's not too bad. Then we do a bit more finding the area under a curve. So you've done a bit of that lower sixth, so that's not too bad. And then we finish with the trapezium rule, which is really quite straightforward. That sort of crops up in the IGCSE a bit. So so we're most of the way there now. So well done. As you know, this chapter breaks down into the 2 unit tests. So if you do get a chance to do that unit test number 1, as I said, we're not really treating it as a test as such. Just think of it as just a worksheet, really. But if you do get the opportunity to get that done, just upload it onto assignments. Let me know that you've done it, and I'll get it marked. So integration by parts. Now, this is just another alternative way how you can integrate something, and it's just comes about by rearranging the product rule from differentiation, which you can see here. Now, the good news, the formula is given. There it is over there on the right. So it's so you don't have to learn it. So what it involves is breaking down the question into 2 components. One bit that you treat as being u, and the other bit you treat as being dv dx. So the u bit, you are going to have, whatever you choose, which component you choose to be u, you will then have to differentiate that to give you du dx, because you're going to be substituting that in over here on the right hand side. The component that you choose to call dv dx, well, you're going to be needing to have v, so that component you're going to have to integrate. Okay, so the skill is choosing which component to call u, which component to call dv dx, because one of them you will differentiate, the other you will integrate. So you clearly want to try and get it the sensible way round. So the one that's easier to differentiate is u, and the one that's easier to integrate is dv dx. So we'll visit that. The only other bit I wanted to flag here, when it says this second component of the right hand side, that's you integrating v multiplied du dx. So almost sort of imagine there's a bracket around both components, right? You're not just integrating v, you are integrating what you get when v is multiplied by du dx. So you'll see that when we look at the examples. So example 16. So they go and say up here under the problem solving bit, where you get expressions like this, so x cos x, x squared sine x, or whatever, it's easier if you just let u be the x term, so you just differentiate that, and that will kind of disappear. And it's easier to make dv dx cos x, because that's easy to integrate. So that's just the problem solving thing up here. So with this question, we're choosing to let u be x, and we're choosing to let cos x be the dv dx bit. All right, so we've basically chosen our u, we've chosen our dv dx. Now, before we can start substituting into the right-hand side formula, we need to get the other bits and bobs. So we differentiate u. Now, obviously, the differential of x is just 1. And we integrate this dv dx, giving us v being sine x, the integral of cos x being sine x. So we've now got these 4 components, 2 of which we were given, 2 of which we've just derived, and we just substitute those in to the formula, the given formula. So we need to have u times v, so the yellow bit times the green bit, and then we need to take away the integral of v times du dx, so the green bit times the purple bit, green bit times the purple bit. And because we went and made u x, du dx is simply 1. That just gives us a very simple integral to do now, because obviously sin x times 1 is just sin x. So our final answer is x sin x minus the integral of sin x, which is cos x. So our final answer is x sin x plus cos x, and always plus c. So that's example 16. And so for questions where you've got things like x cos x, x squared sin x, etc., that will be your approach. Now, you will often get questions where they include ln as part of the question. And the key bit here is, because it's quite easy to differentiate ln x, in other words, it's just 1 over x, go and choose to make ln x your u component, and therefore make x squared your dv dx component, because it is easy to differentiate ln x, and really it would be easy to differentiate or integrate x squared, but we might as well integrate it given it's easier to differentiate ln x. So we've chosen to make u ln x, and as I said, du dx is therefore 1 over x. And when we integrate x squared, we get a third x cubed. And so we've got our 4 components, and again we just substitute into the right hand side. So you do u times v, yellow times green, and then you take away the integral of the green times the purple. The green times the purple, when you go and simplify it, gives us x squared over 3, yeah, because one of those x's cancels out. And then obviously it's easy enough to integrate x squared over 3. That's going to be a 9th x cubed, multiplied by the, raise the power by 1, divide by the new power. So that gives us this here when it's integrated, and then the plus the c. So not too bad. Now, example 18 that we're going to move on to, this is just going to show you that sometimes you're going to have to sort of repeat the process, because it's still not that easy to integrate step 2. So it is sometimes necessary to use integration by parts twice, as we will see here. So here's the question. So we're going to go and let, so it's kind of similar to the first one, in as much they're suggesting go and let u be the x squared and the dv dx be e to the x. Differentiate u is obviously 2x, and integrating e to the x is still e to the x. Now, when you go and substitute in, just following our right-hand side, that's fine. You just go and get this. But this here is still not easy to integrate. So you've got to repeat the whole process again just for this component here. So you're going to let the u bit be 2x, the dv dx bit be e to the x, differentiate and integrate, substitute in, and then finally, you've now left with something that is easy to integrate. So you've just basically had to do 2 lots of integration by parts. First of all, on the whole question, then secondly, on this component of it, and then that took us down to this. And then at that point, because that's easy to integrate, you're fine. So that is, well, I say the last one. That's the last one that I really wanted to talk you through in detail. Okay. The final one, example 19, is just a definite integration where you've just got, you've just got your numbers, your 2 and your 1. So of course they could come up like that, where you just do exactly what we just did. You just do it all by parts, but you've got the extra step that you've got to substitute in 2, see what you get, substitute in 1, see what you get, and take 1 away from the other. So that leads you into exercise 11F. I've done all of those questions on the PDF that you've already had. So hopefully all my work solutions will help you if the model solutions aren't too easy to follow. But as always, if there are any specific ones that you can't do, please just send a post through to me on Teams, and I can go and upload a video explaining any of the questions you like on 11F. This is going to be quite time consuming, so I want to give you 2 lessons for this, please. So this is today's lesson and tomorrow, Thursday the 14th lesson. I don't think I see you on Friday. No, I don't. Then Monday, we'll move on to doing integration by with partial fractions. So that's it, guys. So I hope that was helpful. So I will leave you guys now to be getting on with 11F. So who've we got now? We've got right. Hi, Callan, and hi, Becky. Right, excellent. Okay, guys. So nice seeing you Doms at the beginning to have a quick chat with, and thank you, Callan and Becky, for joining. And that's it. Okay. So good luck with those.
Thank you, sir.
Thank
Cheers,
you.
guys. Bye.
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 Bye.